This is Mr. Beck Does Your Homework, Homework 14, question number 10 and 11. This says if the rotation of a planet of radius 7.83 times 10 to the 6th meters and free fall acceleration 5.4 meters per second squared increased to the point that the centripetal acceleration was equal to the gravitational acceleration at the equator, what would be the tangential speed of a person standing at the equator? Wow, what a crazy question. Well, here's my planet. I've got a person standing here that's zipping around for some reason. As the planet rotates, zoom, 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 the planet's zipping around and spinning as it does, right? Around, we'll just make that the axis. So the person's spinning around, and normally if the person was standing still, the acceleration of gravity would be 5.4 meters per second squared. But I want to spin around such that that much acceleration is what I would need in order to just barely keep my feet on the ground. So that would be like my orbital acceleration. That would be my centripetal acceleration if I was just being pulled on by the gravity. So what I can say is that my centripetal acceleration is going to be, which is v squared over r, is going to equal my gravitational acceleration of 5.4 meters per second squared. So if I know the radius of the planet, then that's my r, and I'm looking for a v. So I can solve this that my v is going to be the square root of g times r, g being 5.4 meters per second squared, and r being the radius of the planet. So that's going to give me the speed that I have to travel in order that this much gravity will provide the centripetal acceleration that I'm looking for. Now it says how long would a day be in this case? Well, if that's my speed, then I'm looking again for my time. So my velocity is going to be the distance I travel divided by the time. So my time is going to be the distance I travel divided by my velocity. Well, one day is once around the planet, so that's going to be 2 pi times the radius of the planet to go once around. And my velocity is this velocity that I had here. So I'll get my velocity from over here. And my radius is given to me. Now, once I get that time, that's going to be a time in seconds. And I want hours, so I'm going to have to times 1 over 60 times 1 over 60, and that'll give me some number in hours. And that's what I'm looking for.